Desktop number 1 displays the hardware management console system management interface that controls the IBM P5 Model 520 server. This server has two Power 5 processors and for the purposes of this demonstration has two micropartitions created. Micropartition number 1 runs the SUSE Linux operating system and micropartition number 2 runs AIX version 5.3 and also has Oracle 10G database installed. Back on the laptop, desktop number 2 displays the output from the Linux operating system and desktop 3 the output from the AIX operating system. Finally, desktop 4 runs a local application called SwingBench on the laptop. This Java-based graphical user interface is basically a benchmarking tool that creates as many transactions as it can per minute against the Oracle 10G database running on AIX 5.3. We'll see more of all this later, so let's get started. So on this first desktop hardware management console display, and from here we can look at the two partitions that we have defined. The first one is running AIX and Oracle for us, and we can navigate our way through to look at the various hardware resources and the processors and memory allocation. And in here we can see this is a capped partition with 0.21 of a CPU allocated to it and some maximum and minimum resources, but the thing to remember mainly is that it's a capped partition at this time. We also have another partition running Linux, and again we can have a look at its resources and see what's allocated to that partition. And again, if we drill down and look at the processors, you can see that this one has 0.65 of a CPU allocated to it and that it's uncapped with a weight of 128, which is a default weight. Now have a look at some of the other desktops we've got. The second one is simply logged into Linux and isn't doing anything right now, and the third one is logged into AIX, which is also pretty much idle at this time. Now just to show you one or two of the standard sort of performance monitoring tools that we use. In the top window here we're running VMstat. It's a standard Unix performance monitoring tool, and it has a few extra sort of columns on the end of it that show how many CPUs we're actually using, and also expresses that as a entitled capacity, a percentage entitled capacity, and we'll return to that later. In the bottom window here I'm running a system management tool standard on AIX, and in here if I just list the SMT mode, the simultaneous multi-threading mode, you'll see that it's actually disabled right now, so I've turned that off deliberately. Okay, let's just exit out of that and let's go and have a look at some other stuff. So up the top here you notice things are pretty idle right now because we're not doing much work in AIX. And if I switch to my fourth desktop, this is our sort of load generation tool for Oracle. And if I have a look at the configuration, what we're about to do is log into AIX and kick off 25 users. Each user basically isn't having any think time at all, so it's just throwing transactions as fast as it can at the database running on AIX. So I start things off and you notice this bar climbs up as we log in those 25 users. And as I begin to do work, 5 different transaction types represented by sort of 5 different bar graphs here, different weightings on each transaction. So we're doing the most of the red type of transaction followed by the green one, and you notice down in the bottom right hand corner here we're recording the number of transactions per minute that we're able to do. Back in AIX you see we're using now 0.21 of a CPU, so we're using our full entitled capacity, which is represented also by the fact that we're 99.7% usage of our entitled capacity on the last column there. This this benchmark tool actually has a rolling average in terms of the display it gives us, which is why that's taking a while to keep up. And Linux here is, well, still doing nothing at this time, so it's completely idle. So the rolling average creeps up and it should settle down hopefully at around the sort of 500 transactions per minute mark, something like that. I can't sort of say exactly what it'll be because it's a real database, doing logging and rollbacks and all kinds of other housekeeping that Oracle does. And you see at the top there, still using 0.21 of a CPU, so we're fully loaded. And yeah, we've settled down around 500. So what I'll do now is a dynamic processor operation on this partition, and what I'm going to do is add some CPU resource to it. So we're currently 0.21, and what I'm going to do is add 0.42 of a CPU. So I just type that into this box here and click OK, and that'll change our CPU resource allocation up to 0.63. so let's set that off, get a message that operation is in progress. And if I go back to the AIX window, you can now see that we've got in the VMstat output 0.63 of a CPU allocated. We're still up at 100%, as we'd expect of our using all of that 0.63 of a CPU, because as I said previously, you know, the benchmark here with Oracle rolling average, yeah, that begins to creep up. So it was 500, so it should settle down at something like 3 times that number. 1100. Yep, let's go back to AX, just check things are okay here. Still using all of the CPU, and we'll just go and have a look at one or two other things that are new in AIX 5.3. This LPAR stat command will show us that, yep, we're a capped partition, SMT is off, logical CPUs is 2, and our entitled capacity here is still 0.63. So I'm just going to go back into the system management tool and just go back to the SMT mode stuff. And you see it's still disabled here, and we'll leave that around for later on. Back in the Oracle window, that's now creeped up to, yep, just over 1500. Probably going to settle around this mark, I think. So that's something to remember, around 1570 transactions per minute that's settled at. So what I'm going to do now is dynamically turn on SMT, simultaneous multi-threading. So this is a new feature in the Power 5 processors that is enabled if you have AIX 5.3. It's on by default. I'd turned it off, but I'm now turning it back on, which is the default mode. And if I do an LPAR stat again, you can see now it says SMT equals on, and notice the logical CPU count has gone up to 4. So the operating system now thinks it has 4 CPUs. And if we go back to Oracle here, you can see that that's starting to creep up above the 1500 mark, and it should settle around about probably the 2000 mark. SMT should give us, I mean, it depends on your application, but it should give us about an additional 25 to 30% in this particular sort of application we're running here, which is, as you've seen, fairly CPU bound. So that rolling average will creep up and hopefully settle down shortly at around the 2000 mark or thereabouts. And yep, there it goes, just up at around the 2000 mark right now, just crossing that 2000 mark. There we go. Okay, so that in effect is like taking a Power 5 system and upgrading it from AIX 5.2, which doesn't have SMT support, to AIX 5.3, and you automatically will get that performance boost. Okay, what I'm going to do now is do another dynamic processor operation. And what I'm going to do now is actually make that partition uncapped with the same weighting as the Linux partition of 128. And when I do this and get this operation going, what will happen is that any spare CPU cycles that are either unallocated to any partition, and there are some in our setup, or that Linux itself isn't using, we can steal. And you can see that in the top right hand corner here, we're now using, it's gone up from 0.63 of a CPU to about 1.9, and our percentage of entitled capacity is around the 300% mark, because it's approximately 0.63 times 3 will get us to something like 1.9 or thereabouts. The LPAR stat command is showing us now that our mode is uncapped and SMT is still on and LCPUs is still 4, but you see there our entitled capacity is still 0.63, but by cycles out of the machine we're actually getting 3 times that amount to work with. And you can see in this window that the rolling average that's displayed here is catching up with us, and we're seeing a lot more transactions per minute by using those spare cycles. So let's make things a bit more complicated. What I'm going to do now is start a program that starts 4 processes that basically use all the CPU cycles that are available on the Linux partition, and you can see that up the top here in this performance display that we're now using, running at 99%, 100% of all CPUs that are available are actually being used, servicing those 4 processes. And now what's happened is, because that partition is also uncapped, back in the AIX partition we're only using about 0.95 of a CPU, and Oracle is reducing the number of transactions it can do per minute because we've got less CPU resource available. So we're still at 150% of our entitled capacity, but because we're fighting, or rather competing with Linux, and have the same weighting that the Linux partition has, it also is taking some of the CPU cycles, the free CPU cycles. So we're both sort of flattening out about the 1 CPU mark in terms of the amount of CPU resource we can use. Now 60 seconds have passed, so what's happened now is those 4 processes have been killed off, so Linux is idle again. And what we can see here is, if you look at what's happening now, we're actually back up to using about 1.9 CPUs worth of resource, and Oracle is climbing up in terms of its transaction. That's beginning to climb back up again as it responds to those additional CPUs being available. Now normally this interaction, this load balancing if you like, between different partitions, actually it's happening every millisecond. So what's happening here is I've I'm changing the load on the Linux partition only every 60 seconds to give us a chance to see what's actually going on. Now on your systems with real workloads that of course are changing all the time and very rapidly, the system will just dynamically, automatically balance those things out according to the parameters that we set up back in the hardware management console. So we see here we go, our Linux processes have started again, and again we're using 100% of the CPU. And if we look again at AIX, you see that we've dropped from using about 1.9 CPUs worth back down to about 0.95. This is a little bit of overhead because of course both operating systems are running, even when they're idle, are consuming some resource, so AIX never gets to use the full 2 CPUs worth, but it comes fairly close. And again we see Oracle responding in its transaction rate dropping down. So this automatic load balancing is great for server consolidation and increasing the utilization of your Power 5 system.